Hey guys, here's a review on the investigation we did about density. As you guys recall, density is a function of mass and volume. And in a couple of the stations that we did, we took a couple of bowling balls and we put those bowling balls in water, and one of them was able to float and one of them was able to sink. And we also put a regular soda and a diet soda in the water, and the one that was regular sank and the diet one was floating. And the big question was why. You had to write a couple of summary statements as to what was going on. Well, here's the basic idea. We know that density is equal to mass over volume, and the one constant here for both of these guys is the volume. The cans are both the same size and the bowling balls are both the same size. Now if you take a look here, look at this bowling ball. This guy here is 14 pounds, and this bowling ball over here is 8 pounds. So the big difference between those is mass. And then if we take a look at the Mountain Dew versus the Diet Mountain Dew, we also learned that the Diet Mountain Dew is much lighter in mass than the Mountain Dew, the regular one, because the regular Mountain Dew has a lot of sugar in there and the Diet does not. So if we take a look at both of these, the volume remains constant. So what that means is this, is if we make the mass bigger, the density gets bigger. Or if we make the mass smaller, the density gets smaller. This is a direct relationship between density and mass. And so what that means is when the mass of the bowling ball increased, its density increased, and then it was able to sink. But for the 8-pounder, because the mass was smaller, the density was smaller, its density dropped to less than the density of water, and it was able to float up. Same thing with the pops. We had the Mountain Dew versus the Diet Mountain Dew. The Mountain Dew had more mass, its density increased, it sank. And the Diet Mountain Dew had less mass because it had no sugar in there and its density was less than that of water, so it was able to float. So the whole thing with these two stations was all about how mass affected density while keeping the volume the same. Alright, in another station we had to play with a lava lamp. And in that lava lamp, it's a little bit of a different situation. You didn't open up the lava lamp and add anything to it or take anything away. So in this case, the mass is constant. So the big question is what happens to density when you change the volume of something? Well, here's the deal. Down here at the bottom of the lava lamp, there's a big light. And that light made the wax hot. So here's the deal. You have this blob of wax. You have the light, and the light put some heat into the wax absorbed the heat, and this wax became hot. But here's the deal. When the wax becomes hot, its volume expands, kind of like a hot air balloon. So this is exactly what we talked about in our weather unit. So the volume will increase. So what does that mean? Well, if the volume increases, what that means for density is that the density decreases. This is an inverse relationship. So because the light made the wax hot, the volume of the wax increased. And when the volume of the wax increased, the wax became less dense. Not only did it become less dense, its density decreased to the point where it was less dense than the water. And when it was less dense than the water, then the whole blob of wax was able to rise. So that's why the wax rose. It heated up, its volume expanded. When its volume expanded, it became less dense. Its density dropped so much that it became less dense than the fluid or the water that's inside the lava lamp, and then the blob of wax was able to rise. But why did it sink? When we take a look at the lava lamp, there's no heat source up top over here. So what that means is, up here, that wax becomes colder. The wax gets cold. And when the wax gets cold, the opposite effect happens. Its volume will drop. It'll shrink back down. And then we go back to our density equation. What's happening now is the volume is shrinking, keeping the mass the same, and that means that the density is increasing. because again it's an inverse relationship. If you decrease the volume, the density will increase. Well, what wound up happening was this, is that the wax became cold, the volume shrank, and when the volume shrank, the density increased. And it increased so much that it became more dense than the fluid inside the lava lamp, and it sank back down. So here's the take-home message with all this, that the heat caused the wax to expand. Its volume increased. And after the volume increased, its density decreased. And like a hot air balloon, it rose right through the fluid because it was less dense than the fluid inside the lava lamp. But then when it gets to the top, it gets cold. And when it got cold, its volume shrank. And after the volume shrank, its density increased. When the density increased, it became more dense than the fluid on the inside, and it fell back down. In another one of the stations, you had to find the density of an object using volume displacement. And all volume displacement means is you put something into water, you measure how much the water goes up, and that gives you the volume of the object. For example, here we have SpongeBob hanging out next to a graduated cylinder. And if we read this graduated cylinder from the bottom of the meniscus, we'll see that the volume is 50 milliliters. Now we throw SpongeBob into the graduated cylinder, and we see that the volume rose in equivalent volume to SpongeBob. So SpongeBob went from 50 milliliters to 52 milliliters. And if I take the difference between them, 52 minus 50, which is 2 milliliters, that gives me the volume of SpongeBob. So the volume is 2 milliliters. But if you remember, we have to get density equals mass over volume. So we have the volume, which is 2 milliliters, but now we need one more part of the equation. We need the mass of SpongeBob. How do we get it? Well, we simply just take SpongeBob and we throw him onto a electronic balance. And we see that the mass of SpongeBob is 50 grams. So now if we go back to our equation, density equals mass over volume, we can plug a few things in here. We know that the density will be the mass of SpongeBob, which is 50 grams, divided by the volume of SpongeBob, which is 2 milliliters. And that means that the density of SpongeBob is going to be 25 grams per milliliter. It turns out SpongeBob is pretty dense. So that about wraps up our investigation on density. If you have any questions, please let me know in class.